Alright, so exercise 9AC, I've just combined them all together. Your aim is to understand what is derivatives and then the power rule. Okay, so it's quite simple in that sense, and it may get tedious to do in the early exercise questions. So 9A and 9B, for example. And the reason being is because you're trying to understand the theory, apply first principles, and then afterwards it's just using rules. So let's get some terminologies out the way. In your exams, they often use the term average rate of change. And later on, you're going to learn another one that's students confused between average value. Those two are very different. Average value links to integration, which is like 2 chapters away from where we are. Average rate of change, that specifically is calculus or derivatives. Okay, so you'll know what I mean once you start doing past exams. Average value is totally different, but students get mixed between the two. Yeah. What's average rate of change? That is pretty much what you did back in year 9. It's simply to find the gradient between 2 points over an interval. So every time they say average rate of change, you'll find that the questions have to give you between x equals 1 to x equals 4. Something like that. It has to be between 2 intervals. Okay. And that basically just means between A to B, what's the change of f of A to f of B really is just rise over run. You see that? Between these 2 points, what's the average change from your starting point to your end point? You're really just looking at FB minus FA over B minus A. That is just your Y2 minus Y1 over x2 minus x1. That's all it really is, if you really think about it. Okay, so you did that back in year 9. We just didn't call it average rate of change. It was just finding the gradient between 2 points. That should be one of the easiest questions you get in the exam style. You're essentially just finding the gradient back in year 9 skill. Okay, so if it helps you, y2 minus y1 over x2 minus x1 is what average rate of change really is. Okay, versus instantaneous rate of change. Instantaneous rate of change would have been the first time you learnt it last year. Last year when we introduced this is the idea where you find the gradient, but not between 2 points, but at 1 point on the curve. So that's what you did last year, where you might get a curve like that, and the question might be, what is the gradient of a tangent line? So a line that actually touches the curve once rather than 2 points. What is the gradient? So meaning the steepness of that line at 1 point. And that's where the theory of first principles, and that's where everything is stemming from, was understanding that concept. Okay, so if they ever say instantaneous rate of change, which you don't often see in the exam, they don't use that term, but you do calculate for that. So that's when you find what is the gradient at x equals a. That's an example of instantaneous rate. Okay. So difference between the two. Your skill for year 11 and 12 is to learn this one. Instantaneous rate of change. Average rate of change, this is your year 9, year 10 skill. Let's do an example so you can see the difference between the two. Here, it says find the average rate of change. So that means find the gradient between 2 points. And they told you, they say for this rule, where it changes from 1 to 5. Okay, so when x equals 1, what is my y value? So this is x1, y1. This is going to be my x2. And you're going to find out y2. Yeah, so this is x1, y1. So here we go. Subbing 1 into the equation, you get 1 squared. Take away 2 times 1 plus 5. 1, take away 2 is negative 1. Negative 1 plus 5 is 4. No, we'll come back. Or we'll come. And then f of 5 is now 5 squared minus 2 times 5 plus 5. And we can see that's what? 25 minus 10 plus 5 gives you 20. So what this basically means is you got 2 coordinates. When x is 1, y is 4. That's the first point. The last bit was starting from x equals 1 to x equals 5. So if x was 5, we worked out that y is 20. Back in year 9 skill, because they're asking for the average rate of change, I'm really just asking, what's my gradient? Here we go. Back in year 9, m equals y2 minus y1 over x2 minus x1. And you can just do 20 minus 4, 5 minus 1. So I'll do the y values first. 20 minus 4 over 5 minus 1. And I get 16 over 4, which is 4. What does this mean? It just means that for every unit you go on the x-axis, you're going up by 4. That's what the rise of a run means. Yeah, so rise of a run just means for every 1 unit across horizontally, you're going up by 4. That's what your gradient represented. Okay? So the first part of the exercise is pretty straightforward. Average rate of change. Everyone should be able to get that answer. The only time you get it wrong is because you're mixing it up with average value, which is more an integration skill. How's that different to instantaneous rate of change? Well, instantaneous rate of change, you won't have a second point. That's why you have to use first principles. But to use first principles, you guys had to learn this last year. Limits. Limits is one of the skills that instead of knowing the actual value, we predict what the value approaches. And then we make a prediction of what the value could be. So here, limit of x plus h has a h approaches 0 if I wrote it like this. So I'm just going to highlight the key thing there. It says here, if x plus h is an expression, and I told you, even though h is a number, so x plus this number, I don't know what that extra number is, but if I told you that this number approaches 0, doesn't mean that's 0, I'm just saying it approaches 0, so it gets really, really infinitely small as close to 0, what would these two expressions add close to? So in the long run, we can say that if this is approaching 0 and it's infinitely small, then x plus something that's infinitely small is closer to x. Okay, that's the idea of limits. So we don't know the actual answer, but we're saying, what if it goes on infinitely, where does that head to? And that's one of the skills that you guys got to get used to evaluating, and that's part of the exercise as well. So here's some practice for you to do under. I'm going to delete these, and I'm going to do probably 2 with you. And then I want you to have a go with one of them. Ah, my God, it's lagging. It's not moving across. Okay, here we go. Let's zoom in a bit. All right. Let's see if I can rub this one out. Okay. I want to rub out the first 2. Notice the last one, I didn't rub it out because it's probably the easiest one to do. Last one says limit of 3x minus 15 where h approaches 0. There is no h. So because h is approaching 0, it doesn't matter. I can get h to equal anything. Doesn't change the expression 3x minus 15. That's why even if h approaches 0, it's still 3x minus 15. Okay? I want to do the first one, and then you guys can have a look at the second one. A few things to be careful of with detail. When you're doing limits in your calculations, make sure to keep lim, h approach 0, up until you evaluate it. Okay, so if you don't keep it there, then you can get penalized for notation there. Okay, so my next line, I still need to write limit h approach 0. What am I going to do? In this case here, I'm going to see if I can simplify anywhere. Actually, I wonder if that's meant to be h to the power of x or just hx. I think that's meant to be hx. Can you change that to just hx, please? Yeah, it should be hx. All right. What we're going to do is we're going to try to simplify this expression to make it smaller and then see what happens when h approaches 0. Here we go. Take out x as a common factor. You get this hx minus 2h, h minus 6. That doesn't seem to make much of a difference, actually. Oh, maybe I didn't even need to. I can probably just look at it and just figure out what the approach is. Limit of h approach 0. I just realized usually you only have to simplify because the denominator might become undefined if you put 0. But what you can see here is as h approaches 0, these two numbers are infinitely small. If they're infinitely small, and that's infinitely small as well, you can see that up here you really just end up with x squared minus 6. Can you see that? X squared minus 6. Because the other two values get so small that they're insignificant to the overall answer, x squared minus 6, whilst the denominator, if h approaches 0, gets infinitely small, then you have a negative 3. So overall, you can say, as limit of h approaches 0, you can see that you end up with, I'll just expand it again actually. Maybe this was a better way. Instead of factorizing it, it was probably better that I had kept the original. And now that I can see that these two values are approaching 0 or making very small, then my next expression I can then say, without writing limit of h approach 0, I would then say x squared minus 6 on negative 3. So if h approaches 0, this is the expression I expect it to simplify to. Okay? Unlike the second example. First example, it was nice we can predict what happens as h approaches 0. What's the problem with this one? If you did the same prediction, if this approaches 0, then you'll end up with, and this one approaches 0, you get 2 squared, which is 4, 4 minus 4, which is 0. 0 divided by 0 approaches undefined. There's no answer to that. So that could be a possible answer. It might be undefined, but we need to simplify to see because it's not exactly 0. It's actually still a number, so technically you can still divide them. So one of the first skills you need to do here, again, remember you got to write limit of h approach 0 until you start evaluating it. So here, the tip is to expand and simplify. Get rid of that denominator h. So here we go. I want you to have a go. I'm going to expand the top for you and then see if you can simplify it down. You get h squared plus 4h plus 4 minus 4. You should take one more step before you get to the answer. Here we go. Have a go with that one. Pause the video for a short bit. Give you 60 seconds. Let's pause the video. All right, so you had a go here. Hopefully you realize 4 take away 4 cancels out. Then what's nice is you end up with h squared plus 4h divided by h. They all have h in their terms. So technically you can simplify it or you can factorize numerator and then remove the h's. What's nice here, if you do remove the h's, you get h plus 4 left over. So this is your next step. Limit of h approach 0. H plus 4. Now you've removed the denominator. Now we can see, instead of saying 0 over 0 before, or a very small number over a very small number and say it's undefined, we can see that actually as h approaches 0, a very small number plus 4 gets closer to 4. So the smaller h gets, the closer you get to 4. So in the long term, I expect it approaches 4. That's one of the skills that just to add on top of your derivative skills, you needed to know how to read limits and then work with limits to then do first principles. Okay, now first principles is a pain. I don't recommend you to do many of them. I do need you to understand how it works and what it does. Yeah, because sometimes the examiners will use this notation, and you need to be able to read that notation and work with it. Okay? This is called first principles. In other words, instantaneous rate of change. This allows you to find the gradient of a tangent line, and this is the key, at 1 point. So in year 9 and year 10, you learned how to find the gradient between 2 points. In year 11 and 12, you were learning the skill to find the gradient with just 1 point. Okay, and that's why you have to learn all those derivative rules. So in the next lesson, I'm going to give you all the rules, and you're going to have to practice chain rule, product rule, quotient rule eventually. And all of that stems from this idea. It's to find the instantaneous rate of change. Okay? All right. Let's do some examples. So for those who aren't familiar with first principles from last year, even if you aren't as familiar, you can kind of skip it. And as long as you learn the rules, chain rule, and all the 7 rules, then you should be all right. But the theory is important to help you understand the application. So here we go. Here's the question from your textbook that could feel tedious. Don't do too many of these. Just do it enough so that you understand what you need to do. Yeah? So here it is. First principle is to differentiate. They want you to find the instantaneous rate of change for x squared plus 3x at x equals 1. Okay, so if I give you a visual, x squared plus 3x, which is really just factorizing, take out the x plus 3. So really your graph is x-intercept at 0 and 3, also negative 3, and it's a smiley shape. That's what your graph looks like. At x equals 1, somewhere over here, this particular point, they want you to find the gradient. What's the rate of change at that specific point? So for every 1 unit across, how many y values are you going up? Okay, so that's the rate. But the problem is you only got 1 point. You don't have 2 points. So here's the theory. This is what first principle says. It's like, okay, well, we only got 1 point to work with, which is x equals 1. But what if I made up a second point? They say, what if I made another point that was h units away from 1? So that means it'll be 1 plus h. You get a second point, a hypothetical point. And this hypothetical point is the whole idea of the theory. See, this hypothetical point that I'm drawing up, this is my second point that I don't actually have. This is where f of 1 plus h is, because if this is the x value, that must be the y value. So, can you see, as I make h smaller, that's the whole point. The theory says, what if I made h really close to 1? Then it's essentially the same as finding the gradient of 1 point. That's the idea. So first, let's find an expression for the y value if x was equal to x plus h. So this extra h was the hypothetical bit. So here we go. This is my equation. If x was x plus h, what I'm asking is, how do you find the y value? To find the y value, you sub in x into the equation. That's what f of x plus h is. So I'm going to sub it into the equation. Instead of x squared, I now have x plus h squared. Instead of plus 3 times x, I now have plus 3 times x plus h. Because what I'm trying to figure out is I want to know if x is 1 plus h, what is, if x is 1 plus h, what would f of 1 plus h be? Yeah? So here we go. Let's expand the brackets here. This now gives me x squared plus 2xh plus h squared plus 3x plus 3h. So far, so good. These all look like a mumble jumble, but remember, these have coefficients of x. Oh, sorry. So x is here. Take out x as a common factor. You end up with x squared plus 2h plus 3x. And you have h squared plus 3h left over. Okay. So what I did there, for those who couldn't follow the algebra, I just took the x from these two terms, factorized it out, so I end up with 2h and a plus 3. So there's my x squared, there's my x, and here's my constant. Okay, so this must represent my c, this represents my b, and 1 represents my a. That's the purpose. Okay, that's my quadratic. All right, now that I've got this all factorized, remember our goal was to find f of 1 plus h, because we're at the end of the day, we're trying to look at x equals 1. So if this was 1, if this x was 1, how does it change things? That means f of 1 plus h must equal to 1 squared plus 2h plus 3 times 1, which is still 2h plus 3. Okay? And then h squared plus 3h. That's all I got. Simplify that. This now gives you what? H squared plus 5h plus 4. Okay, like I said, this whole first principles is tedious, but hopefully you can see what I'm doing. All I just did was I figured out the y coordinate is h squared plus 5h plus 4. This is your x2, that's your y2. So I found x, that's my hypothetical y, and then you still got the first point. When x is 1, what's my y value? Okay, when x is 1, what's my y value? So here, f of x is currently x squared plus 3x. If I have f of 1, so when x equals 1, 1 squared plus 3 gives you 4. So you get your second coordinate. I'm going to draw an arrow to help you visualize that. 1, 4. So you can see on the graph there, I now have 2 points, 1, 4, and 1 plus h, and f of 1 plus h we figured out was h squared plus 5h plus 4. This is what first principles is. It says here, f of x plus h, which is y2, minus y1. So it makes sense. Take this expression, h squared plus h plus 4, take away 4, because that's my y2 minus y1. That's my x2 minus x1. But can you see x2 minus x1, 1 take away 1 will cancel out. That's why you only have h in the formula. So here we go. Let's find the gradient. So remember back in year 9, gradient was y2 minus y1 over x2 minus x1. This is all I'm doing. I'm taking y2, h squared plus 5h plus 4 minus y1, which is 4, all over x2, which is 1 plus h, take away x1, which is 1, and this is where the formula comes from. That's what the formula is. See, h squared plus 5h plus 4 is your f of x plus h. Minus 4 came from finding f of x. And then why do you only end up with h on the bottom? Is because these cancel out. See, they'll always cancel out. And so you end up with this crazy expression, h squared plus 5h plus, actually the 4's cancel out as well on the top. 4 take away 4 cancels out. And this is what you end up with. This is your gradient. H squared plus 5h over h. That doesn't tell us much yet. Because what is h? H I just made up. I literally, on the graph, I said h was just a number that we made a bit more than 1. So look at the graph again. See where 1 was? We only had 1 point. I said, what if I made h just slightly a bit more? That's what h represents here. So in the theory it says, well, what if you made the second value so small, very close to 1, but not exactly 1? You technically have 2 points, but it's so close to the 1 point that you have the gradient of 1 point. That's the idea. But the only way for that to work is I had to look at limits. What if h gets infinitely small? Not 0, but infinitely small. So here's the theory. We then apply first principles, and it just adds in this one extra line, limit of h approach 0. What's the problem? If I put 0 here, you end up 0 over 0. This is why you have to learn how to simplify limits. So here we go. Simplify the expression first. They all have h's. If you cancel them all out or simplify them all out, you end up with limit of h approach 0 for h plus 5. So if I made h infinitely small, what does this approach to? We can see that if h gets really small, and you get a very small number plus 5, It gives you 5. And this is how you find when they ask you, what is the rate of change at x equals 1? I can say now, the rate of change in the infinite zone, it will approach with just 1 point. The gradient at this point must be 5. Gets close to 5. That's the idea. But what you can see there is I use year 9 maths, gradient formula, and then I use one theory from year 11 and 12 to say h approaches infinitely small. That's how you get there. Do you have to do this a lot? No. The examiners will not get you to do this, but the examiners will give you notations in between. You have to be able to read it and know what's happening. Okay, so I tried to keep the notation somewhat familiar, but the examiners won't do that. Your job is to try to get familiar with this. Okay? All right, so if you get those questions in from 9A and 9B, don't do too much of it. Just get a practice so that you know how it works. If all of that falls apart, it's okay. This is what you have to learn as a bread and butter. So for those who really struggle with first principles and notation, copy this down. This is called the power rule. It's one of your first rules to learn. It's your main one to start off with. I've never met a year 12 who couldn't do power rule. It's one of the easiest ones they learn. Everyone seems to know it, regardless. Okay, so here we go. What's power rule? One of the first rules you're going to learn. Power rule is only applied to power functions. Any functions that have a power, you can use this. So, what's the rule say? X to the power of n, so as a single term, it has a coefficient. Then the rule says you can do n, which is the power, multiplied to the coefficient, a, times to the x power n minus 1. That's all you have to remember. So here's an example. So last year you could have got something like y equals 2x to the power of 6. So it's x to the power of 6 term. It's a power rule, or it's a power function. Derivative, delta y delta x, okay, which is the derivative notation, which finds the instantaneous rate of change, finds the gradient at 1 point. How do you do it? Power 6, coefficients 2, 6 minus 1, 12x to the power of 5. What is this? This is this step. See that? So what you did here, all of that stuff that we did up here, the power rule skips all of that and gets here. So when you got up to x h plus 5, this here is this. The only time this changes once you know the value, you sub it in. So in our case, we knew x was 1. That's why it all cancelled out. In this case, we don't know what x is yet. But as soon as you know what the x is, or the first point, you'll know what the gradient is. So for this question, if they said find the instantaneous rate of change for x, y equals 2x to the power of 6, and they say at x equals 1, so using 1 point, only one coordinate, you can sub 1 into this equation now, and that will tell you the gradient. Okay, so this is called the gradient function. And when they ask for the gradient, that's when you need to sub in a point. But it's always 1 point, not 2 points. And that was what you had to learn last year. So last year when we were trying to explain calculus of derivatives, that was the key thing. Derivatives usually find only gradients of 1 point, not 2 points. Okay? All right. Again, you don't need to know the proof, but if you want to know the proof and you're interested in it, in your textbook is on page 353. Okay, you can have a look at that. You do need to know binomial theorem to understand how they simplified that. But do you need to know for the exams? No, you don't. You just need to know how to apply the rule. Okay? Here we go. I'm going to delete all of my calculations here. I'm going to do the first one with you, but you're going to do the next two. And then I'll take a break for today. Okay, so the next few rules, it's all about you expanding and simplifying. So here we go. Example 3, differentiate each of the following. So you might have got this last year as part of your test or exams. We cannot differentiate negative 3x by itself, 5 by itself, 2 by itself, minus x by itself, because they're currently one expression. The rule only works for each term. This is why you have to expand the terms first. So expand the terms, and you get negative 6x plus 3x squared. Then you do plus 10 minus 5x. Now, each of these are individual terms. They're all individual power terms or power functions. And because of that, you apply your power rule to each one. Here we go. I'm going to write it out. Delta y, delta x. So let's find the gradient function. Power for the first one. What's the power for the first function? What kind of function do I have? What's the power? 1. Very good. We know it's 1. So according to the rule, it's n, which is 1, times the coefficient, and then minus the power by 1. So minus 1. Let's do the second one. So we got plus. Let's do the second one. Second one is a quadratic. N is power of 2. So power times coefficient, which is positive 3, minus the power by 1. Let's do the second one, third one. Now, the third one's a bit trickier. Well, from last year anyway. I noticed that students get this one wrong last year, but then year 12s don't normally get this one wrong. 10. What's the power? Ten is to the power of 1. But remember to use a power rule, it's always the variable. This one had an x. That one had an x. Where's the x in this one? X to the power of 0. And it's hidden because 10 is the same thing as saying 10 times 1. But 1 can also be written as x power 0. So according to the rule, it'll be the same idea. Power 0 times coefficient minus the power by 1. And then lastly, that's power 1 as well. Don't forget the minus. Students tend to make a mistake with a minus, so I put a minus there for you. So it's plus. N is 1. Multiply coefficient is negative 5. 1 minus 1. So what is my answer for the derivative? The expression or the gradient function should equal to, that's x power 0 is 1, and 1 times negative 6 is just negative 6. 2 times 3 is 6, and this x power of 2 minus 1 is x, so it's plus 6x. 0 times anything cancels out. 0 times anything is just going to be 0. And your last one is 1 times negative 5 is negative 5, but x power 0 is just 1, so it's just negative 5. Therefore, your answer, delta y delta x, must equal to negative 6 minus 5 is negative 11. 6x minus 11. Remember, this is just the gradient formula. It's a gradient function. It doesn't tell you the gradient yet. You don't know what x is. They have to tell you which point. And they have to give you 1 point. So when they give you one x coordinate, 1 point, you can then find the gradient of that point. So you'll be able to find the gradient of a tangent line for this function as long as you know which point you're interested in. Okay? That was a skill from last year. And this is what I expected. All year 12 should be able to at least do this one as the first step. In your exam 1, that's not the first thing that they'll test. It used to be. These used to be an exam 1 type skill. You do not ever get this one anymore. Your first one is some form of chain rule with product rule. It used to be chain rule for like 5 years from 2010 to like 2015. Then students got really good at it. Now I'm saying it's more chain rule with product rule, chain rule with quotient rule. So you need to know your product rule, quotient rule, and chain rule really well. This is at bare minimum. Okay, so you just need to know your power rule derivatives as bare minimum. Have a go with the next 2, and I'll write up the answers, and then we'll call that a day. Okay? Thanks, team. Yep. Here are the answers. And notice A, B, and C are just different notations of saying find the derivative. So the first one is y, and then it's delta y, delta x. Second one's functions, f of x, so you do f dash x. And then this one, instead of saying delta y, the y is the function written here, so it means the same thing. Okay, so they just tell you what y equals to. So there's change in y over change in x, same idea. Alright. For the last one, simplify the fraction. Just remove the denominator. Factorize and simplify. Alright, I'll pause it there. I think that's enough for today. We'll continue tomorrow after the quiz. And then last last session of this week, I'll introduce chain rule. But to do chain rule, you need to know your power rule. Here we go. We're going to stop.